In this video, we're going to continue our discussion of linear programming problems, and specifically we're going to focus on a minimization objective function with more than two decision variables. So if you need a moment to read this question, go ahead and pause this video, but I'm going to go ahead and dive right in and read the question and start to answer. So Jillian and Dave run a school lunch program. They're trying to decide what to feed the students for lunches. They would like to keep their costs down, but they also need to meet the nutritional requirements for the students. They've already decided to go with peanut butter and jelly sandwiches and some combination of graham crackers, milk, and/or juice. The nutritional content for each food choice and its cost are given in the table below. The nutritional requirements are as followed. Each student should receive between 400 and 600 calories. No more than 30% of the total calories should come from fat. Each student should consume at least 60 milligrams of vitamin C and 12 grams of protein. Furthermore, for practical reasons, each student needs exactly 2 slices of bread to make a sandwich, at least twice as much peanut butter as jelly, and at least 1 cup of liquid, that is milk and/or juice. And what we see here in the table is we see calories from fat, total calories, vitamin C in milligrams, protein in grams, and our cost in dollars. And then along our columns here, we see our food item, and we see that bread is per slice, peanut butter is per tablespoon, strawberry jelly per tablespoon, graham crackers per cracker, milk per cup, and juice per cup. So our first question here is to identify the decision variables. So let's go ahead and identify our decision variables. So we're going to say let B equal the number of slices of bread. We're going to say let P equal the number of tablespoons this is TBSP of peanut butter. We're going to say let S equal the number of tablespoons, so we'll just short form this, TBSP, of strawberry jelly. We're going to say let G equal, I can make that a little bit nicer. Let G equal the number of graham crackers. We're going to say let M equal the number of cups of milk. And we'll let J equal the number of cups of juice. Okay, so here are our decision variables. So we have 6 decision variables in this problem. Importantly, we are very specific about the units of each of our decision variables. So B is the number of slices of bread, P is the number of tablespoons of peanut butter, S is the number of tablespoons of strawberry jelly, G is the number of graham crackers, M is the number of cups of milk, and J is the number of cups of juice. So we've been very specific in identifying our decision variables. This will help you in the long run. So then we're asked to identify the objective function. Now let's take a look at what our question asks us. We're told that they would like to keep their costs down. So in this case, we're going to have a minimization problem. So our objective function we're going to minimize Z. And then all we're going to do is put our costs of each one of these items. So our costs and we're going to build this into our objective function. So It costs 5 cents per slice of bread. So 0.05 B plus 4 cents for peanut butter, 7 cents for graham crackers. So 0.04 P plus 0.07 G. Oh, sorry, 0.07 S. That's for strawberry jelly. Plus 8 cents for a graham cracker, 15 cents for a cup of milk, and 35 cents for a cup of juice. So plus 0.08 G, 8 cents for a graham cracker. We said it was 15 cents for a cup of milk. And we said it was 35 cents for a cup of juice. So 0.05 B plus 0.04 P plus 0.07 S plus 0.08 G plus 0.15 M plus 0.35 J. And this is our objective function. Okay, and now we're asked to identify the constraints. Now, in our problem, we remember reading that we had a number of constraints right here. So let's first talk about our first constraint. So each student should receive between 400 and 600 calories. Okay, and then we look at, well, what are the calories? Well, our calories are in this column right here. So 70 calories per slice of bread, 100 calories per tablespoon of peanut butter, and so on and so forth. So let's go ahead and write our constraint for the minimum number of calories. Minimum calories. So we're told that it's 70 calories per slice of bread. So 70B plus 100P. Where's 100 come from? Well, it's 100 calories per tablespoon of peanut butter plus 50S plus 60G, right? This is number of calories per graham cracker plus 150M plus 100J. 150M plus 100J. And we're told that they need a minimum of 400 calories. So we're going to say that this must be greater than or equal to 400. Now, we're also told that there's a maximum number of calories. Maximum calories. And we're told that this is 600. So we're just going to rewrite this constraint. So 70B plus 100P plus 50S plus 60G plus 150M plus 100J. And we're told that this must be less than or equal to 600. So now we have our constraints for the number of calories, and I'll just rewrite this so that it's nicer. For the minimum and maximum number of calories. So that's our first two constraints. We're then told that no more than 30% of the total calories should come from fat. Well, let's look at where we get fat. So there's 10 calories from fat in bread, 75 calories per tablespoon of peanut butter, 20 calories per graham cracker, and 70 calories of fat from 1 cup of milk. So we're just going to label this, we'll just say that this is fat. And our constraint would look like this. So we're told that there are 10 calories of fat in bread plus 75 calories of fat in peanut butter and 20 calories in a graham cracker. So plus 75P plus 20G. And we're also told that there are 70 calories from fat in milk. Now, interestingly, we notice that there are no grams of fat in strawberry jelly and no calories of fat in juice. Sorry, not grams, calories from fat in strawberry jelly and no calories from fat in juice. So we could write this as plus 0s plus 0j. But of course, because there's a 0 coefficient in front, these are just going to cancel out. So we won't write it down. And we're told that this must be no more than 30% of the total calories consumed should be from fat. So we're saying that this should be less than or equal to 0.3 times the total number of calories consumed. Now, we just did the total number of calories consumed right here. So all we're going to do is rewrite that equation. So 0.3 times 70b plus 100p plus 50s plus 60g plus 150m plus 100j. Now, we could leave it like this, but instead I'm going to put it into what's called standard notation, and I'm going to do this in anticipation that we're going to build this into Microsoft Excel. So I would like to make my life a little bit easier. So I'm going to say 10b plus 75p plus 20g plus 70m, right? Just rewriting what I'd previously wrote, is less than or equal to, and all I'm going to do now is expand the 0.3 through the brackets. So 0.3 times 70 gives me 21b plus 0.3 times 100 gives me 30p plus 0.3 times 50 gives me 15s plus 0.3 times 60 gives me 18g plus 0.3 times 150 gives me 45m plus 0.3 times 100j gives me 30j. Okay, now I'm going to bring all of this to the left-hand side of my equation. So I'm going to say 10b plus 75p plus 20g plus 70m minus 21b minus 30p minus 15s minus 18g minus 45m minus 30j is greater than or equal to 0. Okay, now all I'm going to do is get my like terms and simplify this equation. So 10b minus 21b gives me minus 11b plus 75p minus 30p is 45p plus 20g minus 18g gives me 2g plus 70m minus 45m gives me 25m. And we notice that we do not have a term here for either s or j. So what we have then is minus 15s minus 30j greater than or less than or equal to 0. So this is our constraint for the amount of fat in our diet. Okay, we're almost there. We're then told that the student should consume at least 60 milligrams of vitamin C. Well, there are only 3 items that give us vitamin C: strawberry jelly, milk, and juice. So we'll just say that this is vitamin C. And we get 3 milligrams from strawberry jelly. So 3s plus 2m plus 120j. And we're told that this must be greater than or equal to 60. Okay, now our other constraint here is that we're told that they need to have 12 grams of protein. And what is our protein breakdown? Well, our protein breakdown is found in this, this column right here. So we'll label our constraint here protein. And we're told that there are 3 grams of protein in bread plus 4 grams of protein in peanut butter and 1 in a graham cracker. So plus 4p plus 1g plus 8 grams of protein in a cup of milk and 1 in a cup of juice. So plus 8m plus j. And we're told that this must be greater than or equal to 12 grams of protein. Okay, now we're almost done. We're told that each student needs exactly 2 slices of bread. So bread. So B is equal to 2. We're then told that there must be at least twice as much peanut butter as jelly. So peanut butter versus strawberry jelly. So peanut butter must be greater than or equal to 2s. And all we're going to do is put this in standard notation. So p minus 2s is greater than or equal to 0. And then finally, our last constraint here that's listed in our question is that we must have at least 1 cup of liquid, that is milk and or juice. So our liquid constraint is m plus j must be greater than or equal to 1. And then finally, we have our non-negativity constraint. So b must be greater than or equal to 0. P must be greater than or equal to 0. S must be greater than or equal to 0. J must be greater than or equal to 0. M must be greater than or equal to 0. And G must be greater than or equal to 0. Right, that's our non-negativity constraint. So in the next video, we'll solve this in Microsoft Excel, but that should be sufficient for now. And that's it for this video. Thanks for watching. If this video helped make business analytics easy, consider giving the video a like. And if you need additional help with business analytics, please consider subscribing to the channel. I look forward to solving many more problems with you next time.